Hi, it's Graeme here from OptiSurface, and I'm going to give you a quick demonstration on how to design a building pad in two different ways. The first way is the simplest way, using just a plain best fit, and then I'll show you a more complex way using breaklines, which allows you to have more control and batters and etc. So let's get into it. Firstly, so we've imported our topography and we've turned on the satellite image. Let's say we want a building pad in this area here. So I'm going to right click here, draw new zone. I'm going to put a boundary zone, another boundary zone. Let's say we want our building pad here. And let's make it a plane of best fit. And we're going to have a 0 slope and on a maximum and a minimum of 0. And cross slope, we're going to put 0, 0 as well. And then it's going to balance the earthworks. So let's go ahead. Okay, so now we have a building pad that is flat. If I wanted to edit the pad, I can right click here and go modify extents and say I want to square this up more. I can go to there. Let's calculate again. Actually, calculate landform design. If I want to get more precise with the, I can use these grid lines to guide the points, or I can use this measure tool. So say I wanted this pad to be exactly 450 foot long, I can draw it out here with this measure tool. I can do that. And let's say I want it 450 feet this way as well. And let's make it 400 feet this way. Just zoomed in with the mouse wheel. I can do that. Then from there I can modify this break line to go from there to there, to there to there, there to there. Now to get this one square, if I want to go with this same, this is the bearing from north, so degrees from north, that's 268 degrees from north. So this one's going north-south, this one isn't quite east-west. So if I wanted to get them exactly right, I would click this and watch the bearing number until I got 270 degrees, because that's will be due west. And 450, it's going to be there. So I'm going to delete this other one out that I had. And let's draw another one down here. Watching the bearing, 270 degrees. 450. There. So then I can modify this extents. Go to there and go to there. Another trick is to use these grid points as a guide. So those points come when you calculate the, it's based on this spacing here, so it's a 30-foot spacing, and you can actually rotate those points around. So if I went back to 10 here, click OK and calculate, turn that back on, you can see there's a 10-foot grid there. So I can use that to get perfectly square boundary as well. And then you can see that's the result. I've got a cut fill map there. The earthworks are balanced. If we turn on the existing topography in the background, we can see we're cutting, the pad's going to be there flat. And yeah, that's where it sits. And the earthworks are balanced to the cut fill ratio. So that's the simple way. The more complex way is using break lines, and you'll see the benefit of this method for calculating batters. Okay, so if we right click over here, we can go add break line, or we can just click this one here, which does the same thing, draw a straight break line. So let's say I want to create a pad in this location, but I want it to be, say, let's make it just a bit smaller for the heck of it. It's not what I wanted to come in. You can see that's in edit mode. Okay, stop editing. So now we've got a nice square break line. It's at the same elevation. So let's say I want to calculate the batters down to the existing topography. What I can do is right click on this, go batter, and I want to shoot batters down at, say, let's say I want a 1 in 10 batter going down to the existing topography. But going up, I'm happy to have it steeper. On this side it'll be going up, down, and on this side it'll be going down. So I want to go, I drew the break line this direction, so I want to be shooting the batter to the right. So that means I want to click right here, and I want to shoot to the existing surface. And I'm going to drop this back to 5 because it's a building pad. I'll drop this into 5 and click OK. Okay, so that's what it looks like, and we can look at it in 3D. And that batter looks a bit steep there. These points shouldn't be here. That's the batter going up to the existing surface. Existing surface, if we turn it on, is up here. You can see here, so it's battered down to the existing surface there. Okay, so say I want the, let's do that again. Let's have a look at the batter. Say I want this upstream batter to be a bit flatter. The uphill batter, let's do it again. Just update that to 5. You can see that's flatter now through here. Now, looks like we've got some grid points. All these grid points were from the original landform design calculation, and they are no longer required because we've got break lines. So what I can do is go edit, delete points, polygon select. I'm going to select everything in here. It's going to delete out all these little blue grid points that were there. We can't delete them all. I have to leave some actually. So I'm going to leave some. I'll leave a couple over. And then we get this type of result. Now, we've got no surface through here now. The reason for that is that if we go into Tools, Project Properties, we've got our maximum triangulation set to 300 feet. That means it won't create a triangle. We won't create these triangles here if the points are more than 300 feet apart. So if I change that to, say, 1,000 feet, now it triangulates between them. So we have a flat surface, top. And then if we click on the cut fill map, we'll still have the old cut fill map. It hasn't been updated. So what we need to do is right click, recalculate. We need to select a boundary to calculate to. And we're not going to rebalance. We're not going to change anything. We're going to calculate on a... Actually, we're going to calculate with triangles because they're more refined. Now, see the cut fill map has been updated, but it doesn't go to the batters. That's because this boundary here doesn't cover. So I'm going to modify this boundary here to cover everything. Stop editing. We calculate cut fill. That's boundary 2. Triangles. Okay, now we've got the cut fill map updated. Now these areas shouldn't be included in the cut fill calculation, so I'm going to modify this boundary to cover more precise here, so I can adjust that boundary, insert a point. We go through here. So this is the boundary that we're going to be calculating earthworks on. Recalculating the earthworks on. Stop, so that's B2 there. That's boundary 2. Now I can adjust this arrow size as well. Let's drop that down to 10 so it's not so big. And we can even change the colour of this boundary to, let's do that. And then we go recalculate cut fill, the triangles. So you can see that the cut fill is restricted to that inside that boundary where there's a proposed surface. So here's the earthworks over here. Cut fill ratio is a little off from 1.2, so that reflects the extra fill we've got in these areas here. So we could lower the whole pad to get a bit more cut to make the cut fill ratio closer to 1.2. We could do that manually. We can also do that automatically. Let's try that. B2. Let's rebalance 1.2 cut fill ratio, just break lines. Now we've got a cut fill ratio 1.2. So it's basically adjusted the surface down a bit. So there we go, that looks good. The only other thing we'd like to do is adjust the cut fill legend. So if you double click on the legend, you can modify what it looks like. So let's change this to 1 foot. Gives us better definition of the cut and fill. Okay, I hope that's been useful. Thanks for watching, and if you have any questions, please send an email to support@optisurface.com or give us a call. Thank you.